Hello viewers, welcome to Ekam Academy. So today we are going to discuss about the recent launch by ISRO, that is INSAT-3DS. So this is going to be a satellite which will give you weather forecasting and disaster management related data. So we'll be discussing what are the objectives and what is this series of INSAT, and there is some specific functionalities associated with this INSAT. We'll discuss all that in detail, and also we'll understand what is the basic difference between two types of orbits: geotransfer orbit, geosynchronous transfer orbit, and also geosynchronous Earth orbit. So what are the basic differences, and we will also understand what is a launch vehicle, what is the intended applications of this launch. All these are the things which we are going to discuss as part of this video. So here you can see this is the image of INSAT-3DS satellite. So these are the things which these are the video components we are going to discuss as part of this video. YN News, INSAT series we are going to discuss, and this is third one as part of INSAT series 3DS of the current launch. What is the aim of the mission? GSLV F14, this is a launch vehicle. Then we will understand the difference between GTO orbit and GEO orbit, and also we'll know some facts about Satish Dhawan Space Center also. So this forms part of GS paper 3 under science and technology, and especially under space technology. So you know ISRO is going to launch today INSAT-3DS series of weather forecast satellites or communication satellite. Okay, we'll be discussing this in detail. So first thing you have to remember is what is INSAT. INSAT stands for Indian National Satellite System. Okay, Indian National Satellite System. This is the INSAT full form, and you know this is normally placed in geostationary orbits only. We'll understand what is this difference between GTO and GEO later, but here you have to know all the INSAT series. Okay, till now already 2 satellites are already placed under this INSAT series in the designated orbits, and they're already functional also. Now we are going to place the third satellite. That is what we are discussing, INSAT-3DS. Okay, so why this is there means this is exclusively going to be the weather forecast satellite, and with respect to disaster management, search and rescue operations also, this is going to be helpful. So we'll understand. So what are the main things means? Telecommunication data, broadcasting, meteorology, and also with respect to search and rescue, this is the intended aim and objective of this particular mission. For any mission, you have to know what is a launch vehicle and in which orbit it was placed, and what are the applications of that launch. That is very important for prelims. Okay, so sometimes they can give you with respect to distance or payload also some numerics they can give, and they can trap you there. Be cautious with respect to that. And INSAT is the largest domestic communication system in the Asia Pacific region. So this is a very unique feature of INSAT series. It is not only in India but entire Asia Pacific region. This is the largest domestic communication system. Okay, so you have to know this is the third thing. As I told you already, we have INSAT 3D and then 3DR. These are the 2 already placed satellites as part of INSAT series in the designated orbits. Then you can see these are the 2 things. Okay, 3D launched in 2013 and 3DR was launched in 2016. So then we'll understand what is this 3DS. Okay, as I told you, this is meteorological observation satellite, especially for monitoring land and ocean surfaces, and also for giving disaster warnings. This is what I told you, communication satellite with respect to weather, meteorological data it is giving, earth related data it is giving, and also any data related to search and rescue, disaster management. So launch details. So it is going to be launched from Satish Dhawan Space Center, that is on 17th February, that at 5:35 p.m. this was scheduled. Okay, so by ISRO. Then you know Satish Dhawan Space Center is there in Sriharikota in ISRO. We'll discuss about this. And you know funding, it is totally funded by Ministry of Earth Sciences. Okay, this is one basic thing which you have to know, because most of the students, they'll understand when any launch done by ISRO, they'll think that is coming under Department of Space under PMO, but that is not the case here. It is funded totally by Ministry of Earth Sciences, because it is giving all the earth related data and meteorological data, and even with respect to disaster management. That is why Ministry of Earth Sciences have fully funded this particular launch. And you can see collaboration. It is a collaboration between ISRO as well as Indian Meteorological Department, IMD. Both have collaborated for this launch. Then here you can see what is a launch vehicle, GSLV F14. So GSLV, we'll understand the basic thing, what is GSLV. So this is going to be GSLV F14. This is going to be the launch vehicle which is placed in this satellite in GTO orbit. What is GTO orbit? We'll understand. Augmentation means it will get an augment in terms of meteorological services. Already these 2 previous INSAT series satellites are already there. So to augment services further, we are placing this third satellite also in the designated orbit. Then What is the aim of the mission? To monitor Earth's surface and also to our oceanic related observations, and also with respect to meteorological data also, and we are also collecting some data with respect to like disaster management also, and search and rescue related operations also. We are collecting some basic data. So now, what are the payloads launched? Here you can see imager payload. This is the first payload which is generating some Earth related images, okay, so that we'll have constant observation with respect to Earth and its environment and its weather. Then sounder payload, this is to measure the temperature and humidity. As I told you, meteorological thing, atmosphere related things will be monitored. So it will monitor the temperature and humidity of the Earth all the time. Then data relay transponder, this is another thing which will monitor meteorological data, oceanographic and hydrological. Oceanographic means ocean related data, hydrological means water, and meteorological means with respect to atmosphere. All this data will be collected by this transponder. Then satellite aided search and rescue operations. For this, search and rescue means in case of any disasters. So this particular payload or transponder, it will locate, okay, so it will help in providing faster relief in the disasters. And then we'll understand what is GSLV F-14. This is going to be the launch vehicle of INSAT-3DS. So what is the GSLV F-14 means? This is a launch vehicle as part of GSLV series. So you should know India's launch vehicles, okay. Normally you know anything, okay. For example, if you have to understand, there are two differences. There is a rocket and there is a satellite, right? So this satellite means for what purposes? For example, in this case, we are going to discuss about INSAT-3DS. No, this is the satellite, means this is going to give us some purpose, or it is going to fulfill the mission objectives, means whatever, for what purpose it was tested, those purpose and the objective will be satisfied by placing this satellite. Who will place this satellite? That satellite will be placed in the designated orbit by this rocket or launch vehicle. So in India we have launch vehicles, 4 launch vehicles we have. Initially we have SLV, satellite launch vehicle, that is the first stage of launch vehicles we have. Then ASLV we have, augmented satellite launch vehicle we have. Then PSLV we have, this is polar satellite launch vehicle we have. And you have GSLV, geosynchronous satellite launch vehicle, okay. This is fourth one you have. In the recent times we are also having reusable launch vehicles also, and also we are having small satellite launch vehicles also. These are the new things which we are having in the launch vehicles. But you have to know, these are the two main things which are used by ISRO for many of its operations. So you should know the fundamental difference between these two, okay. So PSLV and GSLV means, when you come to PSLV, so PSLV and GSLV, you have to know the fundamental difference. This is a 4-stage in launch vehicle, you can see. That means solid, liquid, like this. The fuel stages will be there. So once if this stage is exhausted, then it will take the liquid engine, then it will take the solid, then like that it will operate. But GSLV is a 3-stage. So GSLV is a 3-stage, solid, liquid, and you have cryogenics. So what is the cryogenic stage? Cryogenic stage means where the liquid oxygen and liquid hydrogen will be placed in the liquefied temperatures, means you are storing them at a very cool temperatures. So this is an advanced stage in the form of cryogenics we have. This is one of the feature of GSLV. Then what is PSLV? PSLV is considered as workhorse of ISRO, and but this cannot place heavier satellites, okay. So PSLV has a huge success rate, but still it cannot place the heavier satellites and cannot lift off heavier satellites, and it cannot place those in the very distant orbits. That is why mostly for low Earth orbits, that means almost from 160 kilometers to 1000 kilometers of distance. In case if you wanted to use any Earth observation satellites, then you can place this under this low Earth orbit using this PSLVs. And also GSLVs, if you see in the recent times, if for example, even with respect to Gaganyaan mission or with respect to Chandrayaan-3 also we have seen, and we are also aiming for Chandrayaan-4. In all these situations, we are using GSLV, and different variant in GSLV only, because those have to travel a larger distance, means interplanetary missions, or even with respect to any other space related data gathering and all. At that point of time, they need to travel a huge distance and they need to have a huge payload that cannot be carried by the PSLV itself, because their payload is only restricted to around 1000 kgs only, okay, but most of the times. But here if you see, it can carry even 10,000 and 5,000 to 5,000 to 10,000 kg payload can be carried, and even they can place satellites at 35,000 kilometers altitude also. So they have their own advantage. So that is why we use GSLV for these type of launches. And you know, GSLV mostly will be used for communication satellites. It can be used for communication satellites, and also with respect to this Earth observation satellites, and also, you know, in the study of interplanetary missions also we are using GSLV. In this way they have the fundamental difference. So here what we have used is GSLV 14 only. This is a launch vehicle and it is going to lift a mass of 420 tons. This is a 3-stage launch vehicle, as I told you. Solid, liquid and cryogenics we have. Then it is going to serve the purpose of communication, navigation, Earth resources survey. So this is the main objective of this GSLV. Then you can see here also, now we are going to discuss about the GTO and GEO orbits. So first thing you have to know is, here, orbit means what? Okay, orbit is nothing but, for example, consider this as an Earth, okay, and you know, Earth has a natural satellite which revolves around the, that is moon. Means it can be a natural satellite or it can be even an artificial satellite, anything, okay, and or any particular object which is rotating or which you can say which is revolving around another orbit in a curved path, okay. So whichever the curved path which is used by one object to revolve around another object is called this orbit. So orbit is nothing but a curved path used by one object to revolve around another object. So we have different types of orbits. So what is the reason is, you know, satellite has to revolve around this. So you know what is the purpose and due to what, what is the main factor that is causing the satellite to revolve is, you know, due to the influence of gravity. You know, in space there is no air. Because there is no air, there won't be any friction that will be generated by air. That is why only due to the influence of gravity, satellites without any further assistance, they can revolve around this particular object. It can be Earth or it can be anything, okay. So I'm just giving an example here. So we have different types of orbits, like, you know, low Earth orbits we have, polar synchronous orbits we have, and we have GTOs, GEOs we have, and sun synchronous orbits we have. In this way, many number of sun synchronous orbits. Like this, we have different types of orbits. But in this case, we should know the difference between GTO orbit and GEO orbit. So first we'll understand what is GEO orbit. Geosynchronous Earth orbit. So what is this orbit means? For example, if this is Earth, you know, here there is an imaginary line called equator. Above the equator, almost at a height of 35,000 kilometers, above the equator only, there will be this synchronous Earth orbit, okay. What happens is, here in this orbit, whatever the satellite is positioned, so that satellite also will revolve around the Earth in the same way. You know, Earth will rotate around itself in west to east direction, no? In the same direction it will be revolving around the Earth. That means at any point of time, and also it will revolve at the same speed like the Earth. So you know, for one rotation, how much is the time that Earth takes? It is 23 hours 56 minutes and 4 seconds. So the same time will be taken, by the satellite to revolve around the Earth also. That means here, whatever, because of the same time and the same place, and they're taking in the rotating also, they're revolving around the same direction as the Earth is rotating around itself. So when you rotate from any point on the Earth, it also will appear to be stationary, or it also will appear that it is on the same point. That is why we call these orbits as geostationary Earth orbits or geosynchronous Earth orbit, because it is always matching with the Earth's speed and the same direction in which Earth is rotating around itself. So it is above the equator, we have this geosynchronous Earth orbit or geostationary Earth orbit. This is getting placed here. But to get in this particular position, it cannot directly go to the geosynchronous Earth orbit. That is why we take the help of geosynchronous transfer orbit. The name itself is suggesting no transfer. Transfer orbit means initially, if the Earth is here, so for this purpose, okay, so they cannot directly go. So to place this in the particular orbit, so they have to take the help of another orbit. So it is like a transfer orbit. So initially you have to place the satellite in the geosynchronous transfer orbit. With the help of this orbit, from the Earth it will be going to the GTO. This is a GTO, and from here it will take the path of GEO. Okay, that means it is providing a halt type of thing to the satellites which have to be placed in the geo Earth orbit. Okay, so that means this is the first phase where we are placing the satellite using this GTO. Then we'll convert this orbit into the or we'll make this satellite to change the orbit to the geostationary Earth orbit. So this is what the fundamental difference you need to know. Here geo Earth orbit means it follows the same pattern of the Earth, same direction as Earth is rotating, in the same speed at which Earth is rotating itself. That is why it appears to be stationary at the same time. It is placed just above the equator, but not just above, but almost 35,000 kilometers above the equator, and it will be appearing from the equator, you can see, okay. So here you should understand, transfer orbits are a special kind of orbit, that is used by the satellite to get from one orbit to another. Here it is getting transferred from GTO to GEO. So this is the basic thing you need to know. GTO orbits will be a halt. Halt means it is a particular stop, you can say, before they can be placed in their destination orbit. Means before changing the orbit, they will be a stop, you can say. These do not have that directly, because the most of the satellites, they cannot place directly under geostationary Earth orbit. That is why they first have to make use of geotransfer orbit, and then they have to change to the geo Earth orbits. Then what is geostationary Earth orbit? We have seen. The satellites which are placed in here will be appearing stationary, because they'll travel at the same speed like the Earth, and they'll travel in the same direction. That is why, and always if you see from a point from there, the satellite also will be appear that it is stationary there itself, but it is also rotating around the same, like it is also revolving around the Earth in the same speed. That is why it appears to be stationary. Then they are also directly overhead above the Earth's equator, as I told you. And ISRO's Indian National Satellite System, that is INSAT series, is getting placed in the geo Earth orbit. Previous ones also are placed here because it is easy to monitor here. Okay, the antennas will be fixed on this particular part of the Earth from the equator to track the satellites without any rotation. Okay, that is why they choose this orbit to be placed. Then what about Satish Dhawan Space Center? This is in Sriharikota, and Sriharikota is in a lagoon. That is not a complete land type of thing. Lagoon means, again, a part of land which got divided from the mainland, so which is separated from small water body, you can say, or small, like water will intrude from the mainland. For example, if this is the Indian coast, okay, so small part of land, due to erosion or some reasons, it gets disconnected from this part of land and it forms like this, and here water, ocean water or sea water intrudes. This we call as a lagoon. Chilka is also a lagoon. In the same way, this Sriharikota is also based on a lagoon. So this is what you have to know from geography. And this is the launch pad of ISRO. So two types of launch pads we have. Mainly one is used for this PSLV and GSLV launches, and separate launch pad is there for launching the sounding satellites, sounding rockets. If you have remembered, in ISRO there is a sounding rocket called Rohini. Rohini series of sounding rockets are launched already by ISRO. So this is another thing you have to keep in mind. Then coming to yesterday's practice question, which of the following countries are part of I2U2 network? Okay, I2U2 yesterday we have discussed. So now we'll see the answer. USA, yes. So you have two I's and two U's, no? So U's means here USA, and this is not UK. It is UAE, then India and Israel. So these are two for two I's. So I2U2 means it is not Indonesia. So 1, 2, 4 is the answer, that is B. Then West Asian Quad, or also I have discussed that it is new Quad 2.0 we are calling. Then practice question for today, Square Kilometer Array Observatory SKAO is which of the following? Okay, so a newly inaugurated astronomy unit of ISRO, NASA's astronomical branch for the study of distance from the stars, and a new intergovernmental organization dedicated to radio astronomy. And you have ISRO and NASA's joint operation with respect to moon scaling. Okay, so these are the options given. Choose the correct option. And here the main question is, what is India's plan to have its own space station, and how will it benefit our space program? This was already asked in UPSC mains. So now, as we have come to the end of the video, in this video we have discussed about what is INSAT-3DS satellite, what are the objectives intended by the ISRO, and what is the detailed specification of this particular satellite launch vehicle we have seen. And also we have seen the differences between G2 orbit and GEO orbit, and also we have seen about Satish Dhawan Space Center of ISRO. So these are the things which we have discussed as part of this video. I hope you found this video useful. Thank you for watching. Have a good day.